Well, we have a quadratic function, wonderful, with a few different properties. So a rate of increase of 7 when x equals 0, a turning point when x equals 1, and a value of negative 20 when x equals 4. And we're asked to find this quadratic function. So a reminder, the general form of a quadratic is y equals ax squared plus bx plus c. So we have these three parameters, right? A, B, C. And how convenient is it that we have 3 bits of information? Right, see where this is going? So if we get 3 equations for 3 unknowns, it means we can solve the system if it has a solution, right? Which I hope this one does. So what that means for us is, for each bullet point, express it as an equation in terms of A, B, or C, or some combination. So we can then solve for A, B, and C to then get our final equation. Alright, so let's just go in order. So a rate of increase, in other words, the gradient. So to use that information, we need the gradient function. Right, so our general form of a quadratic, that's great, so that's our original function. However, we need the gradient function. So that's dy by dx. So to get the gradient function, we differentiate. So 2 multiplies out the front to give 2 times a. We subtract 1 from the power, which just leaves us x to the power of 1. The derivative of plus bx is plus b, and the derivative of plus c is 0. Right, and that is our gradient function. So with that, we can actually now use write an equation using point 1. So using 1, the gradient is 7 when x is 0. So the gradient is 7 when x is 0. And would you look at that? 2a times 0 gives 0, and we're left with b equals 7. Great, so let's just keep a tally up here. Not a tally, a summary. So b equals 7. So we're a third of the way there. And we've used the first bullet point. Alright, similarly, bullet point 2 tells us that there's a turning point when x equals 1. So how is that helpful? So a turning point, right? Turning point has a tangent line that's flat, right? In other words, the gradient of a turning point is 0. So this tells us that dy by dx is 0 when x is 1. So it's similar to bullet point 1, except they've just hidden that information by saying it's the turning point. So similarly, in for the gradient, we will substitute 0, and in for x, we will substitute 1 into our gradient function. Right, so 0 equals 2 times a times 1 this time, plus b. Well, we know b is 7. And now you'll see that we have an equation, and the only unknown is a, so we can solve. So 2a, 0 equals 2a plus 7, subtract 7 on both sides, and divide both sides by 2. So a equals negative 7 over 2. Or as a decimal, negative 3.5. Alright, so we found A using the second bullet point. Alright, and finally, bullet point 3, it has a value, so the y value, right, is negative 20 when x equals 4. So how is this one different to the other 2 bullet points? Instead of giving us the gradient, it's given us the y value. So we will need to use the original function when x equals 4. Alright, so let's use that now. So n for y in our original function, remember our original function, n for y goes minus 20, a we worked out is negative, I'll use a fraction, negative 7 over 2, n for x goes 4, plus b was 7, n for x goes 4, plus c. And so now you'll see we have one equation and the only unknown is c, which means we can solve. So 4 squared is 16, over 2 is 8, negative 7 times 8, negative 56, plus 28 plus c. Negative 56 plus 28 is negative 28. Add 28 to both sides, we get c equals positive 8. Excellent. So, looking at our scoreboard over here, we found a, b, and c, right? And that's all we need to fully characterize a quadratic function. So let's answer it. So therefore, quadratic function is y equals a, which was negative 7 over 2, or negative 3.5, x squared plus b, which was 7x, plus c, which is 8. And we're done, just like that. So let's quickly go over this question. So we were asked to find the equation of a quadratic function. We were given 3 bits of information, which we had to turn into 3 different equations and solve for the unknowns. Thankfully, they put it in a nice order so that we gradually built up the solution. However, if they didn't, you would still be able to solve it, but it would be a bit more working because you'd need to sort of go back to your other equations. So the first part is if you wrote the general equation, so the original and the gradient function, that is achieved. As you show, you know how to start the problem, right? And you can calculate the derivative. Now, for merit, you had to then equate it to 7 and 1. So that's these 2 points here. Right, you had to use the first 2 bullet points. You didn't need to necessarily find a and b, but you had to show that you knew how to substitute it into your gradient function. And then finally, for excellence, you had to then, of course, find a, b, and c, and find the correct quadratic function.